This presentation is about timeline and interpretation from Shellbags. This is a follow-up to version 1, so this is going to be version 2 of the project, which is going to enhance it in several ways. This is for senior design class, fall of 2020. So you can see this and other projects for this year at reclinicr.com/pitches2020. So here's some high-level details about the project. This project falls into the category of digital forensics. Digital forensics is the process where you examine, say, a hard drive or a system of some sort, and you look for artifacts that help you identify what the users have been doing. Mostly it's in pursuit of criminal evidence. So this is actually a subset of security. So if you're interested in security, this would be a really good project for you. So when users perform many actions on Windows-based machines, such as like opening folders and files, moving them around and stuff, these actions are all recorded in the registry. And the registry artifacts can be used to reconstruct timelines of user actions. And if you've ever taken a digital forensics class, the generating a timeline is one of the most helpful things you can do in order to sort of figure out what happened on that system. So these Shellbags artifacts are stored in the Windows registry. And the Windows registry is essentially a system database that stores, say, configuration items and maybe things about drivers and so forth, and the older ActiveX objects. So these Shellbags, though, tend to be some of the more complicated artifacts to decipher. Most of the other artifacts in the registry are pretty simple. They're straightforward, but the Shellbags it's very difficult to find in fact, it's impossible externally to find the Microsoft documentation. But they are worth the efforts, giving an excellent means to prove the existence of files and folders along with user knowledge. Shellbags can be used to answer the difficult questions of data enumeration in intrusion cases, identify the contents of long-gone removable devices, and show the contents of previously mounted encrypted volumes. So this information persists for deleted folders, and this can give you an invaluable reference for items no longer part of the file system. So even if they delete the files or delete the folders, or and even clean it up with the hard drive, they might even be able to use a wipe mechanism. The data and the artifacts and the evidence is still going to be in the registry. So since this is version 2 of this project, there is a current program. And the current program extracts Shellbags artifacts from the registry. It does parse them. The parsing itself, as I've already alluded to, is not that easy. It's in some structured data that is not documented anywhere publicly. And each different version of the registry requires different parsing. So let's say you have maybe even Windows 8 or Windows Vista. So they do the same thing, but they're all parsed differently. So, and I think even in Windows 10, between this version and the pre-anniversary edition, I think they're parsed differently. So the version of the operating system in the registry is always a factor. In this third bullet point, the Microsoft documentation for Shellbags is not available. You might be able to find it, and if you do, I'm going to give you high kudos for that. So the parsing requirements are kept in a database that's accessible via a REST API, and then that way you just tell the REST API what version you have, and it sends back the parsing information. And then that way we can update it anytime there's a new version. The parsed Shellbags are saved to a CSV file for future study. And in this project, it's not only going to be for future study, but we're going to sort of add to the previous project and use that information to make a lot better sense of this. So the parse shellbacks are currently analyzed in order to create a timeline, and it's actually a pretty nice timeline that it creates. And the timeline is the first step, right? And you can use that in your digital forensics investigations. And then you can actually generate a report based on the timelines in HTML or PDF format. So a lot of times these reports then can be incorporated into the overall report that you would present in court. I should tell you that there are two types of registry investigations. One is for the live registry, whatever is currently in use on a system, and the other is for offline registry hives. And these offline registry hives still hold the same information, but they might be from say an investigation you did, or a digital forensics investigator who got the data off of a live machine and saved it. So digital forensics investigations never operated on the original data. So normally this is actually what you're going to do. You're going to go ahead and take the offline hives and put them on a hard drive and then investigate them. Because you don't want to take the chance that you can alter any kind of information on a hard drive, especially the registry that you're investigating. So this is already being done with this program. So there are other commercial tools, or other current tools. One is commercial. It's called SBag. It's pretty expensive. I think it's about $1,500. It does a good job, but oh no. Okay, so the first part of this project duplicates this, but the program is open source and thus a valuable contribution to digital forensics. Eric Zimmerman's Shellbags Explorer is good, but the thing is, neither of these projects give you a timeline that you can see and use. So you can find the current project on GitHub, github.com/ricklineker/SeeShells, and there is really a simplistic website that you can take a look at. So what do we need in version 2? It's probably what you're asking. Okay, we've already got this program, it works, great. What are we doing? So the current software, I think, is excellent. But now that we have the timeline, we need to be able to interpret the timeline. So what we need to do is research this and figure out what can we conclude in an automated way from the timeline, and put those conclusions up, or make a list of them, or something. I'm not sure the exact format. Probably some sort of a CSV file, or another report would be really good. The user interface is actually fairly, I think, poor. It looks old and dated. I'm going to go ahead and pull that up. I've got the program running right now, and I'm going to pull it up in front of the slides here, and you can see it lacks any kind of pizzazz. So I'd like to, even though the user interface isn't all that important, I'd like to improve the user interface. We need a lot more case studies, because that'll sort of show people how you could use this. The program also needs to automatically run in administrative mode. So right now, if you run it, you didn't run it in administrative mode, then it balks and tells you have to rerun it. We need to do unit and integration testing. So your deliverables is going to be a program that functions without any installation. So this has to be a standalone program, because essentially what's going to happen is a lot of times the investigators will put it on a USB stick. It needs to run off that. Anytime, like on a system that is being investigated, you do like an installation, you've already altered that hard drive quite a bit. So we need a remote database with the parsing information that's already there, but we need a really good way to update it. This parsing information gets retrieved every time the parsing is done. Yeah, so future versions we'll need to update for. A website with documentation linked to GitHub. We've already got that, but it really needs to be spruced up. So additional deliveries, YouTube video explaining shellbags in the program. So that's done, but I don't think it's done very well. We really want to be able to start promoting this to people who are doing digital investigations. All the typical software engineering. It's written as a C# WPF program in Visual Studio, and the server is Heroku on a free tier, and that's going to be perfect. That's all we need. This is not going to ever be a high volume thing, so that free Heroku tier is going to be fine. So we're going to have to do bi-monthly meetings. I have Tuesday and Thursday open, anywhere from 1:30 to 5. We can have